Hello, everyone. Welcome back. Wow, 2 times in 2 weeks. This is kind of getting to be a usual occurrence for us. We're back again with our live streams focused for developers like yourselves. Thank you again for joining us. As always, appreciate you taking the time. We try to do our best to create avenues where we can have you come tell us your wants, your needs, and we try our best to address them, help you with your workflows, your workloads, anything that you guys are having trouble with. Also, we're going to repeat the same format we've been doing in the past. We'll take a pause every so often, ask for you to ask questions. So please ask questions. As I always say, we really want to help the community, and the best way to do that is any kind of direct feedback. And this is your place to do it, to connect directly with NVIDIAns who are working on the products that you're either using or thinking about. So, welcome. Thank you again. Today, we are going to be continuing our TensorRT-LLM journey from last week. We're talking about TensorRT-LLM's new open development model. You'll learn about contribution logistics, adding new features and tests, as well as using CI/CD interpreting results. And I'm joined by two fellow NVIDIAns. Today, we have Mayak, who is the Director of Engineering in the TensorRT group at NVIDIA, as well as Hao, who is a Principal Software Engineer on the TensorRT-LLM team, specializing in large language models. So welcome, guys. Say hello.
Hi, good to be here.
Hi. Great. And so again, please ask your questions, type it in the chat. We're live both on LinkedIn and on YouTube. So with that, I'll let Mike and Hao take it away.
All right, thanks for the introduction, Zach. And hello, everyone. I'm joining you live from NVIDIA headquarters in Santa Clara. And today we're going to be talking about the changes we've made to the TensorRT, to how we develop TensorRT-LLM to make it more open source friendly. So on to the agenda. So today we'll start off by talking about how we've made changes to TensorRT-LLM's development model, how it differs from the way we used to do things previously and the kinds of problems it has solved. We'll do a deep walkthrough on contributing to TensorRT-LLM on GitHub. And towards the end, we will talk about the roadmap of TensorRT-LLM and also talk about upcoming events. Oh, and please keep your questions and comments going. We'll pause every few slides to address questions. And I have my colleagues, Eric and Tyler, online. They're experts in TensorRT-LLM and on our GitHub workflow, so they can answer your questions and I can address them on the live stream as well. First, I'll start with a quick introduction to TensorRT-LLM. It's an open source library that accelerates and optimizes inference performance of large language models on NVIDIA GPUs and NVIDIA AI platforms. And this works on NVIDIA GPUs in the data center, workstation GPUs, and even NVIDIA RTX systems. And everywhere it's used, you use the same APIs, same seamless workflow. It also contains components to create Python and C++ runtimes for orchestration of inference execution. And just a reminder that this presentation is going to have a lot of links. Almost all the links are from our GitHub page. So find TensorRT-LLM on GitHub, and you'll find all the links that we are referencing here. And this presentation will also be uploaded, and it will be available right next to the recordings of this live stream. To the next slide. And so TensorRT-LLM and open source go back a long way. Open source has always been an integral part of TensorRT-LLM for us. In fact, we've been publishing TensorRT-LLM source on GitHub since October 2023, soon after we created TensorRT-LLM. However, there were some shortcomings in the way we were doing things previously. And part of the reason is that the primary backend of TensorRT-LLM used to be the TensorRT graph compiler, which itself is closed source. It's C++. And because of that, that limited us in how much we could open source. And also, most development on TensorRT-LLM used to happen on an internal branch, which was periodically shared on GitHub. But you can imagine that made it challenging to accept contributions from the community. There were many more hoops to jump through. And it also led to longer release latency of TensorRT-LLM features and bug fixes. We couldn't get them out to the public as quickly as we would have liked. Commit history had to be squashed, so that created problems for people who like to follow along and say, if you want to figure out how a feature is implemented, one easy way is to look at the Git history and the specific commits where it was added, look at the diffs. That helps. But with the commit history being squashed, that wasn't really possible. And we didn't have CI/CD on TensorRT-LLM's GitHub repo. Now, I'm happy to report that with our new way of developing TensorRT-LLM, we've addressed almost all of those shortcomings. This new workflow has been enabled by TensorRT-LLM's new PyTorch backend. We had a live stream about this last week. Here's a screenshot from our YouTube page. I highly encourage you to check it out. We're very excited about this new direction. And now with this new workflow, most features and bug fixes are directly checked into TensorRT-LLM's GitHub repo. All Git history is visible. You can see and follow along NVIDIA engineers as they're checking in these changes. PRs are visible. Even our internal changes from NVIDIA engineers themselves, they are checked in through GitHub PRs, and you can look at review comments and CI/CD, etc. And even contributions from from community contributors, they are helped by NVIDIA engineers with reviews, etc., and firing off CI/CD. So all of that is visible. And we have full CI/CD support across several GPU architectures on GitHub now. And my colleague Hao is going to be talking about that in a lot more detail in the next few slides. And continuing our commitment to open source, we have been trying to open source more and more parts of TensorRT-LLM. For example, within the last month, we've open sourced the batch manager, KV cache manager, executor, etc. In fact, just yesterday, we open sourced a lot of customized attention kernels for Decode, and we're working on open sourcing even more. So over the next few weeks and months, you'll see more and more of TensorRT-LLM being open sourced. So here I have a few snapshots from GitHub statistics from the TensorRT-LLM page. You can see that in the almost 1 month since we moved to this new way of developing TensorRT-LLM, how our activity on GitHub has shot up. Almost all TensorRT-LLM contributors are there checking in code to TRT-LLM on GitHub. This includes almost all internal NVIDIA contributors, as well as a lot of community contributors as well. And so it's been very heartening to see the community contribute to TensorRT-LLM. And all PRs, there's been lots of PRs, all Git history is visible, etc.
Yeah, I think community, that's a great keyword. So appreciate everyone taking the time and adding.
Yeah, absolutely. And towards the end of the presentation, I'm going to share how people can contribute even more and how we're looking forward to feedback and where to enter feedback. So we're going to spend some time talking about that as well. Okay, so now I'm going to hand it over to my colleague Hao, who's going to give a walkthrough of how to contribute to TensorRT-LLM GitHub. So over to you, Hao.
Yeah, thanks, Mayank. So before contributing to TRT-LLM on GitHub, please go through some of the most important documentations I have listed here. First, we have the code of conduct, and then the coding guidelines covers both C++ and Python coding styles. And next, there is a contributing.md, which covers the entire developer workflow, including how to submit a PR on GitHub. Then TRT-LLM documentation is the central hub for all the developer documentations on TRT-LLM. So you can find guides on how to build and install TRT-LLM, our API description, deep dives on the TRT-LLM architecture and key features, and performance tuning guides. And we also publish our performance numbers there for every release. Then the next two links, building from source code on Linux and how to run TRT-LLM tests, are important resources for you to build and run TRT-LLM. Next slide, please. Contributing to TRT-LLM is pretty similar to how you contribute to most open source projects. First, you create a fork and git clone the repository locally. One difference is that we use Git LFS to store some large artifacts in the repository. So you need to install Git LFS and run these two commands before you start building. Then you're ready to create a development branch with Git checkout. Also, like before you make any changes, it's probably the best practice to build and install TRT-LLM first, and to make sure your environment setup is correct. Run some example scripts in the repo, or like run the unit test to make sure everything is set up correctly. Then you can make your changes at your unit test and test your changes. Before making a commit, we recommend to install pre-commit and run it on your changes. We use pre-commit to automatically format the code and do validation. It's also run as part of CI. So make sure to remember this step. After you make your commit, you can push your changes to your fork and create a pull request. For security reasons, only NVIDIA engineers can kick off the CI/CD right now. So after you make the PR, an NVIDIA engineer will need to be assigned to help you review and kick off the CI. So after the PR is reviewed and approved, and you fix all the CI issues and the CI passes, we will merge it to main. Next slide, please. So moving on to adding unit tests. So our unit tests are all under this path, test unit test _torch. And they are organized into these subdirectories. Auto deploy is an exploratory project that automatically imports Hugging Face LLMs into TRT-LLM for easy deployment. So all the tests for auto deploy goes here. And then we have the torch compile test in compilation, and modeling test and modeling for the single GPU model level test. Modules is for torch module tests such as linear attention, MOE, those go here. And multi-GPU includes unit tests that require multi-GPU communications. Example is RReduce or like reduce scatter, those kind of tests go here. And multi-GPU modeling are model level tests that require multiple GPUs. Like for example, if you want to test your Llama model with TP4, and those kind of tests go here. Speculative coding test is the next one, and THOP is for all the PyTorch custom ops we have added to TRT-LLM. To run the test locally, we recommend to use PyTest. Next slide, please.
Just to jump in really quick, if anybody has questions, please ask. We can pause at any time, and also take some time at the end of the stream.
Okay. Okay, moving on to CI. So TRT-LLM has support for GPUs from Ampere to Hopper to Blackwell. So we have all of these different types of GPUs in our CI, like A10, A30, L40, A100, H100, H200, and B200. For adding tests to CI, the guideline is to pick the cheapest GPU with the desired hardware capability to run the test. Because we have we have a lot more like A10s than B200 in the CI. So this is to make sure that your test doesn't slow down the overall CI. So for hardware specific test, please pick the right hardware with the right capabilities. For example, FPA tests can run on both Hopper and Blackwell. So typically you would choose H100. And FP4 tests can only run on Blackwell, so you will have to use B200 for these kind of tests. And for each GPU type, we have a YAML file that corresponds to this GPU. And right now, for historic reasons, we need to manually add tests to the YAML file to make sure the tests are invoked by the CI. And then these YAML files live in this testDB. Is there a question? No.
Actually,
okay.
yes, there is. I can bring up a question.
Yeah.
Any customer quality GPU support for TensorRT-LLM tests?
Maybe there are about RTX.
Any consumer, sorry, not customer.
Oh, consumer, like RTX?
Yeah, Ray, if you can be a bit more specific.
I think TRT-LLM can run on GeForce, but it's mostly for data center.
Yeah, so just to add, we do support TensorRT-LLM on RTX GPUs as well. There's several people who focus specifically on that. And as part of that support, we make sure those GPUs are in CI. So yes, we run those tests on consumer GPUs as well.
Okay. Jetson.
There's another question about if it can be used with Jetson Nano.
So I'm not specifically sure about that Jetson Nano 4GB, but on Jetson, yes, we are actively developing support for Jetson Nano as well. Sorry, for Jetson as well. I'm not sure yet about Jetson Nano.
Great. I think we can move on. We'll bring up the questions as they appear.
Okay. Next slide. Okay. To add a unit test to CI, first, it takes a few steps. So first, you need to determine the right PyTest command line to run your test. Here are a couple examples. You can run test in one directory or in one file, or filter the test through some keywords or PyTest mark. And then you want to check the YAML files in the testDB and make sure your test cases are not already covered by existing ones. For example, I think most of the tests in the current directory in unitest_torch are invoked automatically. And then choose a suitable GPU and add your test cases to the right YAML file in TestDB. And next slide, please. Integration tests live under a different path. Test integration devs. There are more tests than what I have listed here, but these are the most relevant ones to the PyTorch workflow. First, we have accuracy test. These cover end-to-end accuracy test for models. The standard ones we have are MLU, GPQA, and the summarization tasks there. Then we have disaggregated serving tests to test the disaggregated serving end-to-end. Next, we have test e2e.py, which has model level end-to-end tests. So you have seen that previously in unit test, we also have some model level test. Here is another place that have a lot more end-to-end like tests for different models. Adding a new integration test is very similar to adding a new unit test. Just follow the same process and make sure your tests are in the right YAML file, so the CI will actually run your test. Adding new models is a bit tricky. First, you probably need to submit a GitHub issue and then trigger a discussion with our engineers. And then this will be reviewed on a case-by-case basis. Once the models are approved, and we will add the models to CI and make those available to the community. Next slide, please. Yeah, you can also run the integration test locally. It requires one more step because integration test typically requires a real model. You first need to download the model locally from Hugging Face and point this environment variable LLM models route to your local path. Yeah, and then there might be more pip packages you need to install locally with pip install to run them. These are some of the examples on how to use PyTest to run the integration test. Next slide.
Just to jump in really quick, Hao, for those people wondering, we will make these slides available publicly. We'll upload them to the description, either the YouTube or LinkedIn. And before you move on, there's another question if you guys want to take that one.
Sure.
So in order to use the embeddings and VectorDB to use along with TRT-LLM, is there a recommendation or suggestion?
Embeddings of VectorDBs. If they're large, I think we will need to first upload it to the storage system we have for CI. Yeah, this will need to be, it will need some help from our TRT-LLM engineers for this. Yeah.
Was this a question specific to CI or just in general?
Yeah, locally you can do anything. Yeah.
We've also been getting a lot of questions about consumer GPUs. So, you know, I think Tyler and Eric in the background, our mods are helping out there. I can put them on screen. TRT-LLM can be run on a 4060, but with reduced memory. It'll limit the models that can be run, and a 5090 is recommended if you're using a consumer GeForce RTX card. And also for Jetson Nano 4 GB, it'd be tight on memory, so that there may be limited capabilities. Not yet officially supported, but team is working on it, as always. All right.
Okay. Okay. So TRT-LLM CI. To trigger the CI, we use a bot to launch the CI job. So on the PR page, we use comments to interact with the bot. For example, here in the comment, you put in / bot run, and then this will kick off the CI pipeline. And the bot will post the pipeline link back through comments as well. After the CI pipeline finishes, the bot will also comment. The bot will also post the CI result with a comment. Here, like the first line, you should ignore that, and that just means the bot run itself finished successfully, but the actual pipeline failed with failure here. Next slide. To check the CI result, you would typically scroll down to the bottom of the page, and Blossom CI is our infrastructure for running CI. And you go to the right and click on the 3 dots, the more actions button. Next page. Next page, please. No, go back one more. Yes. After you click on the 3 dots, a new button will appear, View Details. And after you click on the View Details, we should go to the next page. A new page should appear. Next page. Yes. So here it will show you more details on the pipeline results. And then the test failures should appear here. And most of the time, you should also see the logs on why the test failed. And sometimes the logs will be filtered out, and you will need some help from your reviewers on getting the detailed log. You can also run the test locally to see if there's, to debug the failed tests. Next slide, please. Here I include some of the most useful, frequently used scripts to test with TRT-LLM. First, we have the quickstart.py. It's used to run a Hugging Face LLM model with simple prompts. And then the quickstart advanced.py is usually used to test out different runtime features and combinations, such as different TP, PP, EP configs, or like to turn CUDA graph on and off, or to test out different decoding algorithm or like speculative decoding algorithm. Next, we have quickstart multimodal.py is used to run multimodal model. And there's one more script, MLU API.py, and we use this to run MLU test with LLMs. Any questions?
No additional questions at the moment, but please ask questions. This is the time for developers, for you. So feel free to just drop them in the chat. Either one of our team members behind the scenes can answer it, or we can answer it on cam.
And I think I'll have hand it back to Mayank.
All right, thanks, Hao. So that was a lot of information, and just another reminder that these slides will be uploaded, so you can refer back to them when you do contribute to TensorRT-LLM. All right, so in the next few slides, I'm going to talk about a preview of the roadmap of TensorRT and also upcoming events and how you can get involved with TensorRT-LLM development. Now, we, as part of our push to be more open, we have also published TensorRT-LLM's high-level roadmap on GitHub. So I pasted a few screenshots on how to get to that. You click on the projects tab, and that will get you to the roadmap. And there's a few items populated for the next quarter for the roadmap. And caveat, it's a very active project, so things might change, but for the most part, we will keep it accurate. A few salient features from our upcoming roadmap plan. We will publish pre-built dev and deployment Docker images. We prepare for the 1.0 release of TensorRT-LLM, as part of which we will add backward compatibility guarantees to specific APIs. And a lot of these are mentioned on the roadmap, and you can click on the links to get more information about some of these items. We'll continue to close the gap between the previous TensorRT-based backend and the PyTorch, the new PyTorch-based backend. We'll add optimizations for expert parallelism to improve MOE inference performance. And there's a few more that I'll leave them here for you to read later. Next, I think this is the exciting part for us. How can the community contribute to TensorRT-LLM? Now, I'm happy to say that we already have started seeing a lot more community contributions to TensorRT-LLM. And please do contribute more to TensorRT-LLM features and bug fixing. We want to develop this in synchronization with the community. Here's a sample list of features to contribute to. You can go to the Issues tab on our GitHub page and check out 3706, 3704. There is more. There's a longer description about what these things are there. And to find more such opportunities, look for the Community Engagement tab label. You can search by that label within TensorRT-LLM issues. Also, we are very eager to hear feedback from the community. So please share your feedback, your feature requests and comments and questions to the discussions page, or you can post them on issues. And to get to the discussions page, you just click the discussions tab on our GitHub site, and you can classify your questions or comments into one of these categories. And then finally, please do attend more TensorRT-LLM live streams to know more about the things we've been working on. So there was a live stream last week. There's one that you're attending right now, and there will be more that we are planning. For example, we'll talk about DeepSeek R1 performance optimizations in TensorRT-LLM, and also TensorRT-LLM engineering baseline efforts. You can find out more about upcoming events by following the NVIDIA AI LinkedIn page or the NVIDIA AI developer page on X, and also the YouTube channel for NVIDIA developer.
Great, thanks for that plug.
Right. And then we have a Discord. So you can use this QR code to log on to the NVIDIA developer Discord. So we're happy to hear from you on Discord as well. So I'll leave. This was the, yeah, go ahead, please.
No, go ahead.
So this was the last slide, and I'll leave the QR code page here. And back to you, Zach.
Great, thank you. A lot of information shared, as Mike was saying. This will be recorded and available later. We'll also upload the slides. But before we finish, there are a slew of questions that have come in. So if you guys don't mind, I'm going to bring them on screen, and then feel free to answer them. So we have a question here. Does TRT-LLM support dynamic batching for unpredictable request patterns like content feeds?
How you're muted if you're.
Oh, sorry. We have in-flight batching support. I suppose that dynamic batching means the same thing. Content feeds. If if there, the content feeds is still text, I think it's supported. Multimodal is, if it includes pictures, it will need a multimodal to run it, but it should be supported.
Great, thanks. All right, let's move on to the next one. I think this is a common question. What is the difference between TensorRT and TensorRT-LLM?
Mayank, you want to take this one?
Sure. So TensorRT is a product family, and previously TensorRT used to refer to the graph compiler itself, which is a closed source library. And TensorRT-LLM was a specialization of TensorRT for LLMs. Since then, the TensorRT brand has expanded, and now it includes a slew of products. There's TensorRT Cloud, there's TensorRT-LLM, but TensorRT-LLM as a product, which we are talking about here, focuses on LLM acceleration.
Great. Here's a fun question. I'll get to that later, but we'll bring this question up. Do you have benchmarking compared with VLLM?
TRT-LLM does not publish benchmarking compared to other frameworks, but VLM has published benchmarks compared to TRT-LLM. So you can check out the VLM benchmarking numbers. And also we have benchmarking numbers for, in the TRT-LLM repo, and you can also cross-reference those with the VLM numbers.
All right, we have more questions coming in. Are you planning Hugging Face integration for push and to deploy support? Or is that up to the community?
We have the auto-deploy project to import a Hugging Face model directly into TRT-LLM. So that's our current Hugging Face integration. It's not integrated into Hugging Face themselves, but more of Hugging Face integration into TRT-LLM. And you're welcome to contribute to that part of the project.
That's the key word, welcome to contribute. So contribute. We do have also, I can share a link in the chat of the public roadmap for TRT-LLM for anyone interested. I'll put it into the chat. All right, more questions. DeepSeek R1, Distill Llama 8B, running locally on a 4060. How can and will, I guess, TensorRT benefit this person?
Like if your case is batch size 1, you may not need a framework to run those, but if you're running like let me think, even for batch size 1, I think TRT-LLM like has speculative coding, which can speed up your request, and we have MTP support. That's for the full model, and we're working on Ego 3, which can bring speed up 1 to 3x, which is nice for local use cases.
Great. There is one question left. It's a little more out of the ordinary. Where can I get Zach's cool shirt? We do give away shirts from time to time during either contests, or we have meetups either regional or locally in the San Francisco Bay Area, we do raffles and drawings. I encourage you to come and attend, and you just might win one of these either funky colored or black shirts that you'll see NVIDIAns wear. I think that's about it for the questions, and we're kind of running out of time. So are there any last minute questions that I can encourage and squeeze out of the audience? If not, I think we can slowly wrap up. Also, as a reminder, next week, Wednesday, we have another live stream with our NVIDIA Dynamo team. So if you are wanting to learn about Dynamo, come and attend that event. We also have a meetup for NVIDIA Dynamo that will be happening some point within the next month or so. So keep your eyes open on NVIDIA channels for information and more about that. That's a live IRL in real life person event for developers, anyone interested, enterprise. If you're a manager or if you're a developer engineer, open to anyone. And we encourage you to continue the conversation on our Discord, on our channels here on YouTube, LinkedIn. Please post them into the comments. We'll try to get our people, either Hao or Mayak or anyone else, Tyler, Eric, behind the scenes to see if they can address those questions. Oh, wait a minute. We got more questions coming. Okay, let's see. I have another question about, will the new open development model eventually support fine-tuning aware optimizations like quant-aware adapters?
Yes, we're adding LoRa support right now. It should work for Llama already.
Okay, and another question. What does an ideal contributor ecosystem look like in 6 to 12 months?
So I can take that one. Yes, obviously the answer is that everyone on GitHub contributes to TensorRT-LLM, and it's the most popular project on GitHub. But in all seriousness, we want to co-develop TensorRT-LLM with the community. We want to engage the community actively and encourage people to contribute features and bug fixes, and also communicate to us, provide us with feedback on the things they like about TensorRT-LLM that we should continue focusing on, and the drawbacks that they see for their use cases, so we can go and fix those. So we want lots of communication with the community.
Great. I think we'll wrap it up here. But as I said, please go to the forums or Discord to ask questions. If you have them, you think of something after you step away, have your coffee or whatever it is, warm milk that you tend to drink, no matter where you are right now. But I just want to thank everyone for joining us again on this live stream. We created this kind of series for you to come and ask your questions. Have our teams more accessible, just like Mayak and Hao. And, please join us in the next one. So with that, I want to thank you all for joining us. And thanks to our mods in the background, Tyler and Eric, and Joe. Thanks a lot.
Thank you, everyone.
Yeah, thank you.
Oh, I heard the cat.
Oh, yeah.